Problem F18-4, 50 kilogram wheel subjected to a force of 50 newtons. If the wheel starts from rest and rolls without slipping, determine the angular velocity after it's rotated 10 revolutions. The radius of gyration of the wheel about its center is 0.3. So let's start out by finding I. So I is equal to mk squared, which is 50.3 squared 4.5. Now there's two ways to solve this problem. The first way would be to solve it using energy, V1 plus T1 plus work equals V1 plus T1. Now we could do this saying, well, let's do this linear. So first of all, V1 is 0, and V2 and 2. This is also 0 because there's no MGH and there's no springs. And also it starts from rest, so this is 0. So we have work equals T2. Now if we do this in a linear way, we need the sum of the forces in the x direction, which would be, breaking down P, it would be 43.3 in the x direction. The y direction, not important. So the sum of the force in the x direction would be 43.3 minus the force of friction. Force of friction going back that way. So then the work is force times distance, 43.3 minus the force. And the distance, 10 revolutions. So the distance is 10 times 2 pi times the radius, 0.4, which equals 8 pi. So we'll put force times distance, and that equals 1/2 mv squared. So distributing the 8 pi, we get 1088 minus 25 force of friction equals 4 omega squared. We put in omega r for V, and r is 0.4. So we get that equation, and then we have to sum the moments, and that equals sum the moments times theta, sum the moments times the distance, equals 1/2 I omega squared. Okay. So now the sum of the moments is the force. The force causing it to rotate, and that's the force of friction. So we're going to use the force of friction times the distance, 0.4, times the angle of rotation, 10 revolutions, so that's 20 pi. That equals 1/2 I 4.5 omega squared. So solving this equation, we get the force of friction is equal to 0.0896 omega squared. Putting this into right there, and we get 1088 minus 25 times 0.0896 omega squared equals 4 omega squared. Distributing and solving, we get 1088 equals 6.24 omega squared, and omega equals 13.2 radians per second. The other way to solve this is again using V1 plus T1 plus omega equals T2 plus V2. And that's 0, and that's 0, and that's 0. and the work is equal to, and this time we're going to count the rotation in with this. So we're going to do 1/2 mv squared plus 1/2 I omega squared. Now this time when we use work, instead of using force times distance to be the difference of the 43 and the friction, we're not going to count for the friction, because the difference of these two is what translates into the linear of the wheel. If we don't account for the friction, that's the force that will turn some of the linear momentum into rotational momentum. So if we consider just the 43 times the distance, that's our total work, and that will cause both the linear momentum and the angular momentum. So, or linear energy and rotational energy. So if we just use the 43.3 times the distance, 8 pi, we'll get both 1/2 mv squared m is 50, v is 0.4 omega r squared, plus 1/2 I 4.5 times omega squared, which is getting kind of small there. So now we can solve for directly. So now we have 1088 equals 4 omega squared plus 2.25 omega squared. So 1088 equals 6.25 omega squared, and omega equals 13.2 radians per second. So here this is accounting for both the linear and rotational in one equation. And you'll note that this ends up being the same as, well, these two added into that. And so this times this was the same as that, being the rotational in both.